First Spin. Welcome to First Spin, a show where I learn how to use the Parallax propeller without having any prior programming experience. And rather than do this on my own, I have enlisted the help of...
I'll help.
And me.
I'll help and me. All right. Where did Roy and Whisker go?
Well,
I don't know. Well, what?
Here.
do you have any questions or not? Because
Yeah, okay. All right, I had
got stuff
a
to do.
question. So, one, Roy, excellent job on explaining counters. It helped a lot, even though I had to ask you more questions later. But I have a question. Can you... Okay,
seems
so...
like a lot of other people liked last week's episode as well.
I did. Well, because it was extremely useful in clarifying what was not clarified previously.
Huh.
Mhm.
Well, I kind of understood it, but Roy's got some mojo going on there with the counters.
Right.
I think him and the counters have a thing.
I think so. But okay. I have a question. So FRQA, whatever it may be, accumulates every clock cycle, well, depending on the mode, into PHSA, right? Can FRQA be a equation? Be an equation? Or does it have to be like a decimal value?
No, it's well, it has to be. It's just a register, so it just has a 32-bit value in it, right? That's
Mhm.
all. That's all that's in FRQA. The mechanism is either FRQA gets added to PHSA every clock cycle or not. There's like disabled, so it's
Mhm.
not. But
Right.
the default thing is every clock cycle it will get added, or based on the pin state, right?
Right.
Changing. So if you set up the counter to be in positive edge detector mode, then it will only copy FRQA into PHSA when the appropriate pin state is valid.
Okay.
But that's really all you can do, and you can do either all the positive and negative and edge stuff, or you can do the logic stuff, which is comparing A and B, the two different pins with each other.
So you kind of could, because if it's based on a pin being turned on, right? Like pin
Right.
detect, then behind that pin you could have your equation.
Right,
doing
but it's
whichever.
still not the value that gets added to PHSA from
Oh, I
FRQA
guess
is
that's
the
true.
same value every time. It's just whether it gets added or not has, logic behind whether or
Right.
not.
I see.
That's all that's allowing you to choose.
I see. Okay. Well, and if you guys have any more questions about counters and such, just let us know in the comments section, and we can go over those.
Yeah,
Yeah.
as we get through the introduction episodes here of just getting Addie familiar with the overall language, we'll probably have a little bit of time each show to answer a few questions from all of you guys too. So yeah, please do comment on the episodes at firstspin.tv. It's pretty easy to leave a comment.
Yes. Okay.
Right.
So that's all I was wondering. Just if you could,
Right.
yeah. Okay.
I understand.
I'm good.
Okay.
So we go on to video configuration, which is actually very cool.
Yeah. So one of the things that with the VCFG and VSCL registers, they're used to allow you to configure the video output of the propeller.
Mm-hmm.
And then they work in conjunction. You set those up, and then you use the wait vid command, which you've probably seen when you were looking at wait CNT and wait PNE and all those.
Mm-hmm.
The problem is using these from Spin is not super effective because you can't really drive them at the rate they need to be driven to produce a video signal.
Okay.
So you pretty much only use them from PASM
Okay.
to set up, to actually render a screen with these. You could set up the registers in Spin, right? You would configure what mode and whether it's VGA or composite and which pins and all that. You can set all that up in Spin, but once you actually want to do video, you need to use the waitvid command, and generally in PASM, so it can go fast enough to feed the colors out to the video signal very quickly.
Okay. Well, I think at some point I'm going to want to learn how to do video, just because.
Yeah.
That's
well,
cool. But
as a from Spin, there's already several objects that come with the prop tool that allow you to do like text on a TV screen or on a VGA screen, or to do simple graphics. And they're pre-written objects in PASM that you can call from Spin to do video. So
I see.
It's not like you don't have the ability to do video. It's just that these particular registers and the instructions that go with them aren't something that you're generally going to do from Spin code.
Okay.
And we're kind of focusing on Spin first.
Right.
And maybe later on we'll have an advanced Addie show where once she's an expert in Spin, we'll start teaching her PASM.
First PASM. Wait. Cool.
So we can do a quick rundown. So the video config thing is literally just letting you select which mode, whether it's VGA or composite.
Okay.
And composite is like NTSC or PAL. Okay. And the difference is just in timing. And then you have setting up a few different things about the mode, like whether it's 2 colors or 4 colors, and some other details about how the signal is generated for the composite stuff. And then the other one, VSCL, is just to scale how many clocks each pixel is and how many clocks each frame is, so that it will output at the appropriate rate to drive your display at an appropriate resolution. Okay. And those are like only a handful of clocks per pixel, and in order to set up a color in Spin, it would take dozens or hundreds of clocks, and so you wouldn't be able to go fast enough to draw pixels.
Gotcha.
And so that's basically those. And like I said, they work together with the waitvid instruction and command.
Cool. Sounds good.
I'm sure there's somebody out there, some expert Spin guy that has like managed to do some, low resolution video with just Spin, but their timing had to be, just right. And it was like probably really limited.
Yeah, you could probably use the counters to do it with a little trickery on a TV with just the high value, low value, and ground. If you got your counter going the right speed, you could spoof a composite video signal that way.
That sounds very tricky. I don't know if I'm up to tricky levels of.
Mark Van de Wettering has done it.
Really?
Yeah.
But on a different platform.
Oh, I see.
Yeah. The thing is that you could probably get that working, but it's not as useful as just the normal write up the code in PASM and get actual bitmap displays.
Right.
And there's plenty of objects available that do all different kinds of resolutions and colors and sprites moving around the screen and parallaxing bitmap layers and all kinds of fun stuff out there.
Cool.
Already written for you.
Okay. Sounds good.
And then the very next register, by the way, we're on page 41 in the manual for you listeners.
Those listening, yes.
Propeller manual version 1.2.
Mm-hmm.
So the next register, the PAR register.
Mm-hmm.
Again, this is one that's really only used with PASM because it's how you pass a parameter from your Spin code into the PASM code.
Okay.
So basically what happens is you set the PAR register to something, and then the PASM code can read the PAR register and use it. And people tend to put like the beginning address of a set of variables into par, and then the PASM code can read that address and then access those variables using various assembly instructions. Okay.
Yep.
And then the last register, the SPR register, we've mentioned this in the past, I believe, but it's basically it stands for a special purpose register.
Mm-hmm.
And it's an alternate way to access all the registers that we've gone over the last few shows.
On PASM? Via PASM?
Well, via spin.
Oh.
SPR is a spin. So you would say, instead of dir A, you could do SPR open bracket 0 close bracket. And that will give you the same thing as doing dir A.
Oh, so like SPR open bracket
It
3
points to the entire register section of memory.
would be
Right.
in NB.
So as long as you know the offset for each one of those registers, you can access them directly with SPR.
So if you go to page 200, the actual order is slightly different than what we covered. So if you actually go to page 200, it will, there's a table there of which index is which register. And you happen to be right that 3 was in B.
Sweet.
I was wrong about dir A because it's not the first one. It's actually 6.
Okay.
The first one is par. So index 0 is par. Index 1 is the count register.
And there's a total of 16 registers. So you got your 0 through 15. And the first couple of them, the first 4 are read only, and the rest of them are read write. And I know some of you guys are getting a kick out of me abusing the out B as a register, just a general purpose register. You could do a lot of that trigs with all the rest of them that are read write as well, as long as you're not hooking anything up to those at the moment and using them for anything else. You could abuse them all that way. So there's 12 registers there that you could probably abuse as a really fast, quick memory that you have individual bit-by-bit access to using the brackets.
Yeah,
that's
and
convenient.
one of the things to be careful of when doing that kind of thing, though, is if you happen to use counter A or counter B as a general register, it's going to cause the counter to get into a mode that might modify PHSA because it's going to copy whatever's in FRQA into PHSA every frame. Add every clock cycle. So, generally people stay away from using the counter ones as general purpose, but you could definitely use the frequency and phase registers as general purpose if you have the counters disabled.
I see.
And a lot of people do that.
So use with care. This is very hackish sorts of stuff, but it is there.
I see.
It's just sort of a shorthand, quick way to access some stuff sometimes.
Let me just double check. If SPR open bracket 3 close bracket equals 1, then that's the same thing as if in B equals 1.
Right, but that would mean that in B, the entire in B would have to be all zeros and then the bottom bit being 1.
I see.
Right, so, and that will be true. In B doesn't connect to anything, so it'll only be true if you ever set in B to something.
Right.
Or out B to something, I think, actually, is how that works.
Okay.
Because in B is read only.
Right, well, okay. But you know what I mean. I was just trying to figure out how to write it. If I were to decide to use that method.
Oh, yeah. The SPR. So one use for the SPR thing is you could write some code that would work with counter A or counter B.
Yeah, we explained this several episodes back. I mean, we covered it. I mentioned that when you're designing it inside of an algorithm, that your algorithm is more flexible in that it can use one or the other.
Right.
Okay.
So that's one case, but most of the time, most people just don't use SPR at all.
Okay. I probably won't, to be honest. If I just have the commands, I might as well just use those.
Yeah. Well, sometime in the future, when there's future Addie who's like a spin expert, she might go back and use SPR.
We'll see about that. All right. Constants. True, false.
Constants are fairly simple. We kind of covered them already when we were talking about constants before.
Yeah.
This is just defining the 5 constants that are predefined as actual fixed values,
Okay.
true and false. One thing that to note again for people, we mentioned this, is that true is not
1.
a positive number, it's
Negative.
-1.
Yep.
And the reason is because -1 in binary numbering on a 32-bit value is all the bits on. And that's handy.
So doesn't that equal 2 to the power of 31?
Yeah, well, it's FFFFFFF and hex, or all ones for all 32 bits.
Oh.
And so the handy thing about that is that you could say, out A equals true, and that will set out A all the bits on, right?
Mm-hmm.
And out A equals false. False is 0.
So everything's false. I see.
Right. And so it's a handy way to do true and false. And I actually kind of prefer this way. Some languages work this way and some don't.
Okay. As opposed to saying set whatever to 0, or
some languages false
sign,
is, 0 and anything else is true.
Right.
Oh.
There's all sorts of different ways to, go about this, but,
I see. Okay.
So the next two are just handy for doing math operations. So you have POSX and NEGX are just the maximum positive value and the maximum negative value that an integer in spin can hold.
Mm-hmm.
So a long in spin. It's just, the 2,147,483,647.
Right.
Is POSX. It's just the largest number that's positive.
I see.
Right. And same thing for the negative.
Okay.
And they're useful for like checking against or, doing other various math with. And then the last one obviously is pi. But the thing to note is that it's pi in floating point form.
So if you use it, you need to do floating point math.
Right. And you can only do that in normal spin code. You can only do that at compile time, like we've talked about in the past.
Mm-hmm.
But it's useful because you could do math in your con section. You could do some math that involves pi, and you don't have to write out 3.1415. You can just use pi, and it'll give you that approximate value of pi.
All right. Gotcha.
Okay. So the next...
But again, always remember that the floating point stuff is mostly compiler stuff, and it's, you're working inside of your float directive stuff, and it's all messy and... Right.
Well, it's not that messy.
Says the expert.
You can't really do it at runtime without some, libraries and stuff to help you.
Right. Like the float 32 or...
and that's going to have its own pi, so this doesn't really apply to doing that at runtime, I wouldn't imagine.
Well, actually, you can use this pi with those.
Nice.
So it's handy.
I have no idea what you guys are saying, but until I have to worry about floating point math, I'm good.
Well, I think in the future we'll probably do a show with how to use the float math library to do something interesting, because it is useful stuff for people to use.
Okay.
So this variable here, they're just talking about result is automatic.
Mm-hmm.
You know this because we've covered it, but
come across this one.
An automatic variable in any pub and pry method that you have in your code.
Mm-hmm.
You automatically have a result variable that you can just assign values to, and that value will be returned back to the caller that called your pub or pry function. And it's just an automatic variable that the compiler just injects into your function if you need it, and we'll use it.
So the main function doesn't really use,
every function does this. The main one in your program normally doesn't. It just returns back to nothing, right? No, it got called by the propeller starting up.
Yeah.
But if you happen to call, build a different spin program that included your program through the OBJ section, then your main function would return back to that when it got called.
And
there.
one of these days, we'll have the joy of explaining to Addie the call stack.
Huh? Are you confusing me already?
No, I'm
Right.
just, when you get that far, we'll explain it, and then you will achieve enlightenment.
I see. Okay. Until then. Yeah, I think we did come across this. Was it in X? I'm currently working with the XBees.
Addie has been working in binary a lot lately.
Yes.
Even though she said on the show that she refused to learn binary and hexadecimal, she's been using binary a bunch.
Well, that's because binary math is very interesting.
Isn't it, though?
It's kind of tricky.
And it's also really handy for programming.
Yeah. So if you guys don't yet know, we come out with a video every Wednesday, and I think the past 3 or 4 weeks, I've been going through interfacing the XBee with the Propeller, and a lot of the code involved in that is tricksy. I think, but
She's also been doing some code analysis on all of this stuff, breaking it down and figuring out how it works line by line.
Yes.
And some of it's actually pretty, like she said, pretty wound up on itself. The binary, bit shifting, that kind of thing. So, Addie's learning.
I am. It's true. And I'm a little scared because I've just started to actually make my own code. Like, try to cobble together bits of code that I understand, some that I don't, to get it to work together, and it's been incredibly frustrating. But once it works, it's like it's very rewarding.
You can find all the extra material of this sort of thing at tymkrs.com. There's a link there to the videos and a link there to the blog posts on Tumblr.
Right.
Yep.
But on that note, let's go to the Unary Operators.
Well, we've got like 8 minutes. You sure we don't want to leave these for next week and maybe answer some question? I know you've been doing a lot of actual coding this week.
Oh, well, let me see.
Is there something that you actually wanted to ask just from what you're working on?
Let's see. I've been mostly using the XBee to try to control an RC servo. So wirelessly control an RC servo, and then also wirelessly control my Heart project.
And just to be clear on that for the listeners, is she's got one propeller board with an XBee, and it's sending to another propeller board that has an XBee, and that other propeller board has the servo hooked up to it.
Correct.
And she's pushing a button on the first one, and it's causing the servo to change directions on the other one.
And
it's not wirelessly directly connected to an XBee.
She's using the new Propeller Board of Education boards. They have a slot on them for XBees, and she's using the XBees that are available for sale at Parallax, the little kit that they have.
Yeah, the Parallax wireless kit. It has a USB adapter, a
5 volt to 3.3 volt conversion adapter.
Right. And then
2 XBees.
2 XBee modules. So very convenient, very awesome. And the tutorial written, I believe, by Martin Hubble.
Right.
Is excellent.
The Board of Education, the Propeller Board of Education is available for pre-order right now. And I believe it's coming out like middle or end of this week when you hear the show.
Yeah. So
really soon now you'll be able to get your own.
Yeah, pre-orders have been up for a while, but I think they're like getting ready to start actually sending a few out.
Yep.
I am looking through my code to see if there is anything. I think if you had talked to me yesterday, I would have been just like, why is this not working? But now that it's working, it's kind of like, oh, it makes sense.
So you ran into a brick wall with your code, basically. What did it turn out to be? Can you sort of like explain what your process was of trying to trace down the problems? And
well, I asked
did you
Roy.
learn anything?
okay, so my first project was this RC servo, right? And I was trying to use the XBee tutorial code, and I tried to keep as much XBee code as I could and inject as little RC servo code as I could. But I actually kind of learned that I could use more of the RC servo code. I know this is a very disjointed way of explaining it, but essentially, the only thing that the XBee needs to worry about is that serial transmission from one node to the other. Once it has that information, you can pass that information on to the propeller. And then the propeller can just do everything from there on. So you don't actually need the XBee to do anything per se, except for pass information. And that was a big step in how I addressed the heart project, because then I didn't try to have the XBee control the heart, because that would have just been crazy complicated.
Right.
I could just give the information.
So you basically sort of figured out that you just need to use the XBee wireless as just like a serial connection between the two. You hand off some characters to send and let it send it over, and then on the other side you're like, give me the characters that you got sent from the other one.
Right.
And then you do everything with those characters that you want to using your normal propeller code.
Right. So I think getting past the idea that I needed to use the XBee for anything besides transmission of like a single byte of information helped.
Or multiple
bytes. Yeah.
Now that you got one, the next step would be to be able to get strings sent over and be able to parse them, and then you're getting into protocol design.
But see, that's exactly what I think would happen. So, because you're saying parse them, that parsing would be done.
That's what I'm an expert in, is protocols.
Right. That parsing would be done by the propeller, though, not by the XBee. Right. Whereas I think before I tried this, I would have made the XBee try to do that, which is kind of confusing because that's not how it works.
Yeah, and it really can't do very much of that. It can do only very minimal amount of stuff based on configuring it with commands.
Right. And then I was able to include the starting of new cogs with the XBee.
Right.
The XBee communication. So that was cool. So what I had done for the heart project was I had originally started the XBee communications on the receiving side, and then started receiving the data. Then after receiving the data, starting the cogs, and then having the cogs go through the information through what it had received. But that actually threw an error.
Right.
So what I had to do was change the order a bit. So I would start the communications for the XBee, start the cogs, and then receive the data. Yep. And then receive the data. So
yeah, because what was happening is you had your loop receiving the data, also starting the cogs again, and you eventually run out of cogs because you weren't stopping any cogs.
Dun, dun, dun,
dun.
But you figured it out. Like, you realized that you needed to move those cog news for those heartbeat cogs outside of your loop up to the top, so they would be started, and then just set the values for them inside of the loop.
Right. And I think the thing for those who haven't programmed with Propeller, with Spin, I should say, is new, is that cogs don't have to be called by anything necessarily. Like, you don't have to say initiate the use of this cog. It'll just start in the order that it's coded in. Does that make sense?
Well, when you do the cog new or the cog init, that will get the cog going.
Right. But it's not processing anything until it has something to process, right?
Well, it depends on the code that you have running in the cog. Your code in your cogs was sitting there in a loop waiting for a variable to change, and then it would do something, right?
Right.
So you had your setup so that in the main program you would set that variable, and then the cog would read the variable and change its state. Right?
Right.
So you didn't actually have to, once you got it set up, you don't call a function necessarily to make the cog do something. You just set a variable that the cog happens to be paying attention to.
Right. Right. And so I think that's apparently different from what some other languages do, or what some other...
well, on a lot of other processors, you're basically bouncing back and forth. You don't have multiple cores necessarily.
Mm-hmm.
So you don't have stuff running at the same time that can all just work. It's got to switch contexts around and do other more advanced stuff that's kind of beyond the scope of this conversation. But in general, yeah, it's one of the nice things actually about the Propeller is that you can do that if you have pieces of code that are independent, and you can just start them going, and they can be running on one of the cogs and doing their thing, and your main program can go off and do its own thing.
Mm-hmm.
Right?
Yep. So, I mean,
So you got that all
two
working.
projects working in 2 days.
I'm guessing
So
that'll
pretty
end
happy.
up in this week's video on Toymakers.
Actually, it's probably going to be about 2 videos from today.
I see.
Next week, or for them this week, only because we're going in order of the tutorial.
Well, all right. People can subscribe to the YouTube channel and get it whenever it comes out.
Yes.
All right.
It will be shortly.
Yes, it will be.
That's all the time we have for this week. Thank you for listening, everyone.
Thank you.
And you can find this show every Tuesday at firstspin.tv. Addie and I and Roy are all on Twitter. You can find information on how to contact us in the what is the about
the show
part on the website.
Yep.
Right.
All right. We'll see all you guys next week.
Bye.
Bye.
Bye.